Year 11, here's a quick review of fractional indices. So the opposite of raising a number to a power is finding the root of a number. Finding the root of a number is expressed as a fractional index. So we can write if x is equal to, x has a power of 1 over n, some fraction, what that stands for is the nth root of x. Similarly, we can extend these to link in with the other rules we've learned. So if it's negative and fractional, then it'll be the reciprocal of the nth root. If you've got a fraction that has a denominator other than 1, then we know that normally if we raise a power of an exponent, then it's like either squaring, cubing, etc. So if we have some fraction m over n, then we have the nth root, and then our pronumeral x is to the power of m. And we can express that in two different ways. Both will give us the same result, whether we find the nth root and then raise to the power of m, or whether we raise x to the power of m and find the nth root. And so it's just a reminder, if we've got a negative indice, we can flip to the bottom there. Okay. So moving on to a couple of examples. Example 1, evaluate 49 to the power of a half. Well, what does that mean if I'm raising it to a half? Well, it means I've got the square root of 49, which is 7. B, 27 to the power of 1/3. That means I've got the cube root of 27, which is 3. 3 times 3 times 3 is 27. Okay, 8 to the power of 4/3. Well, let's write that as it's the cube root of 8 to the power of 4. Now, I've written it like that because it's going to be easier to do the cube root of 8 than raise 8 to the power of 4. Though you can just put this on your calculator and it would evaluate it anyway. But if we had a algebraic base, that means like instead of the 8 being an x, then you'd need to just be able to express it in this way and you wouldn't be able to evaluate it. So cube root of 8 is 2. So this is really the same thing as 2 to the power of 4, which is 16. 2 times 2 times 2 times 2. Okay. Write in index form. So we're now going in the reverse way. We are changing these guys into just index form. Okay, so if I've got the square root of x to the power of 5, then what that's saying is I've got some fraction which is numerator is 5, it's raising to the power of, and the denominator is the square root, x to the power of 5/2. Okay, looking at the bottom one here, if we want to write that just in index form, then we're going to be removing that fractional part. So really this is the same thing as 1 over 4x squared minus 1 to the power of 2/3. Because you've got a cube root there at the bottom. And if you were writing it with negative indices, you could actually just flip that to the top if you wanted to. And so it would be 4x squared minus 1 to the power of negative 2/3. Though it doesn't really specify that we need to do that in this case. The main thing is, can you take something like x to the power of 7 over 5 and then make it into the 5th root of x to the 7. That's really what we're trying to do. Okay, so last one, write x to the power of negative 3 over 5 without negative or fractional indices. Okay, so x to the negative 3 over 5. If I'm taking out the negative, I could just make that 1 over x to the power of 3 over 5. And now if I'm changing that, I've got 1 over the 5th root of x cubed. So your goal with the exercises is to be fluent in moving and manipulating expressions with fractional indices, even multiplying them together. So like x to the half times by x to the 3/4, knowing there that you've got to add the powers. So all these sort of questions will work in the same way. You're just dealing with fractions. So in this case, x to the half is the same as x of 2 over 4 times by x over 3 over 4. And so if I add those together, I would have x to the power of 5 over 4, which if I wanted to, I could write that as 4th root of x to the 5. Okay, good luck.